So now I'm going to look at a few of the problems using the exponent table. Sometimes as the numbers get larger and the roots get larger, it's easier to use the exponent table to find what we're looking for. So if I start with number 13, which is negative 625 raised to the 3/4. Well, the first thing I need to realize is where the negative is located, and it's located outside of the power in the root. It's essentially saying take -1 and multiply it by 625 to the 3/4. And if I rewrite that as a power and a root, I prefer to take the root first so that the number becomes smaller and then raise it to the power. So if I rewrite this as -1 times the 4th root of 625 cubed, then I'm looking for what number times itself 4 times is 625. So I look in the exponent table under 4, find 625, and follow it back, and find that the 4th root of 625 is 5. So this becomes -1 times 5 to the 3rd. If I now want to know what 5 to the 3rd is, I can look across my chart at 5 until I find 5 cubed, and I'll find that 5 to the 3rd is 125. So I'll have -1 times 125 equals -125. Now let's look at number 14, which is asking for -81 to the 3/4. And notice the difference between where the negative is here as compared to the question in number 13. This question is saying take -81 and raise it to the 3/4 power. And again, I prefer to take the root first so that I can make the number smaller. So it will be the 4th root of -81 raised to the 3rd power. And when we see it in this format, we should notice right away that a negative to an even root is not possible. So in this particular question, there is no solution. Now let's look at number 16. 16 has 36 to the 1/2 plus 125 to the 2/3 minus 81 to the 0.25. Well, the first thing I'm going to do is rewrite that 0.25 as a fractional exponent. So I'll have 36 to the 1/2 plus 125 to the 2/3 minus 81 to the 1/4. And now I'm going to start writing all those fractional exponents as roots to powers. So 36 to the 1/2 becomes the square root of 36. 125 to the 2/3 becomes the cube root of 125 squared. And 81 to the 1/4 becomes the 4th root of 81. Now the square root of 36 we probably all know is 6, but the cube root of 125 maybe not so much. So if I look in the exponent table under 3 and find 125 and follow it back, I find that the cube root of 125 is 5. So this becomes 5 squared. And likewise, if I want to find the 4th root of 81, I can look in the exponent table under 4, find 81, follow it back, and I find the 4th root of 81 is 3. So I have 6 plus 5 squared, which is 25, minus 3, and 6 plus 25 is 31, and minus 3 is 28. And the last problem I want to go over with you is number 29, which I've already put up here. There's a lot going on here, so I'm going to see if I can simplify a little bit first. I'll keep the 729 and the 64. But I notice that I have x's in both the numerator and the denominator, and the rule when we divide is to subtract. So if I subtract 12 from 30, I end up with x to the 18th left in the numerator. And if I subtract 18 from 24, I'll end up with y to the 6th in the denominator, and then raised to the negative 1/6 power. Raised to the negative 1/6 power basically says that everything's going to change its location, so I'm going to put everything in the denominator in the numerator, and everything in the numerator in the denominator, and make the power positive. Raised to the 1/6 power says I can take the 6th root of everything. So I'm going to take the 6th root of 64 y to the 6th and the 6th root of 729 x to the 18th. And if I want to find what times itself 6 times is 64, I'm going to go to my exponent table, under 6, look for 64, follow it back, and I find out that that is 2. And y to the 6th, the 6th root of y to the 6th, is just y. So the numerator becomes 2y. And if I do the same thing, but with the 6th root of 729, under 6, I'm going to find 729 and follow it back and find that the 6th root of 729 is 3, and the 6th root of x to the 18th would be 18 divided by 6, so that leaves me with x cubed in the denominator. And my final answer would be 2y over 3x cubed.